Okay, now that we've finished lesson 1-1, now we get to really work hard and start another lesson today. Section 1-2, at least part A, not that bad, okay? It's called rates of change, but in reality, the whole thing is about average rates of change. You have seen that the slope of a line can be interpreted as its rate of change. Actually, the slope is literally known as the rate of change. The rate of change function is defined as, let me get really fancy here, the rate at which the output quantity changes with respect to the input quantity. Basically, what are the y's doing as x gets bigger? That's what that says. If the graph of function is not a straight line, so if it's curved, if you have a curved line, it's kind of hard to find the slope because from what you know, slope requires 2 points, right? So if you were to connect 2 points, you don't have a curve anymore, you have a straight line. But that's what we have to do when we have a curve until we have calculus. That's what we have to do. We have to select 2 points and literally find the slope between those 2 points. That is the average rate of change, also known as the AROC. Legitimately, take 2 points, x1, y1, x2, y2, on a curve and find the slope. Nothing crazy about that. It's literally just the slope between 2 points. They just happen to be on a curve. And you saw me do that in yesterday's lesson. Here I was finding slopes between 2 adjacent points. Here I was finding slopes between points that were not adjacent. All of these things that I've drawn, though, are average rates of change. Well, the numbers that I've written would all be average rates of change because I connected 2 points on a curve with a straight line. But it's just the slope formula. It says find the average rate of change of this cubic. These are x's. This is x1 and x2. And if I know x's, how do I get y? Just gotta plug them in, yeah. So let's get our coordinates. We have 1 comma, let's see, 1 minus 4, negative 3. And 3 comma, 3 to the third is 27. 27 minus 12 is 15. So on this cubic, the average rate of change between x equals 1 and x equals 3 is calculated by 15 minus, use parentheses please, negative 3 over 3 minus 1, 18 over 2, 9. Okay.
Can you show how you got the points again? Like the one.
Yeah. So what I did was, I did f of 1, which means I plugged in a 1 for x. So 1 minus 4.
Okay.
And then I did the same with the 3. 3 to the third is 27, and then minus 12. Just plugging the x's in, getting their corresponding y's. The slope between these 2 points, the average rate of change over this interval of x's is 9. That's it. There's nothing else to it. That's all we're doing. Cool? How'd I get what? The 9, the 18, the negative 3, the 50. How'd I get what? Yep, I was plugging these x's in and getting these 2 y's and then finding the slope. The table below, oh, by the way, AP, College Board, they love to take real world chunks of data and ask questions about them. It really puts a application spin on the kind of math that we're learning. The table below is data from the University of Michigan's Center for Sustainable Systems that shows the U.S. annual municipal solid waste, the MSW generation. MSW is commonly called trash or garbage. So basically we're talking about how much garbage that we are making in certain years. And it's common household, office, retail waste, doesn't include industrial hazardous or construction waste. Okay, whatever. The point is, we've got years and millions of tons of trash. That's what's going on here. These are our x's, our inputs. These are our y's, our outputs. Find the average rate of change in the trash between 1985, the year I was born, and 1990. Right there. So it's just these 2 coordinates. Remember, these are your x's and these are your y's. So where was I? 85 and 90, right here. So 208.3 minus 166.3 over 1990 minus 1985. That's going to give us 34 plus 8, 42 over 5. If you need to, grab handy dandy calculator and get 8.4. 8.4. But remember, AP is going to require you to write your units. This is millions of tons of trash per year. That means we took grouped data. If you notice, it was grouped by 5 years. We looked at growth across the 5 years and then divided by 5 just to see what the average growth was every single year. Average rate of change. Not too bad, right? It's slope. That's all we're doing today. Slope. Looking at this huge table of data, did the rate of trash ever decline in this entire 58-year span? Where did it decline?
2005 and 2000.
There you go. From 2005 to 2010, there was a decline. We went from 253.7 to 251.1. That's the only decline. And what was that rate of change during that period? These are my x values down here. These are my y values down here, so they go on the top of the fraction. So 251.1 minus 253.7 over 2010 minus 2005. Almost wrote 2050 by accident. That's going to give me negative 2.6 over 5. Grab a handy dandy calculator. Click a bunch of buttons. Negative 0.52 millions of tons of trash per year. You don't have to put it in decimal form. A question like this would probably be specific about how to have your answer written, or it would be a multiple choice question, one of the two. The AP exam has a multiple choice section and a free response section. And unless they dictate how to write your answer, you don't have to put it as a decimal, but you would never leave it like this. This is weird. So because it already has decimals in it, and this already has decimals in it, you might as well get to a decimal answer.
Like for like example 1, if it was like just some like odd fraction, would you leave it as a fraction?
Like if it had been 19 over 2.
Yeah.
Again, I think that would be multiple choice. So as long as you're comfortable with it being the same, you're good to go. Question for me back there? Sir?
If we're writing a decimal,
Yes.
that is less than, like between 0 and 1, like negative 0.52, would we be marked wrong if we omit the 0?
No, you don't have to write the 0. I just like to write the 0. That way it was obvious that this was my decimal point.
Okay.
The only thing that you have to be sure of with AP is that you round to 3 decimals. This is where this one ends. But if the decimal goes further and further and further, you have to round to 3 decimals. That's the only rule. But no, this 0 is not required to be written. I think in chemistry it might be a sig fig or something like that. I'm not sure how sig figs work in chemistry. But for AP, no. Just round to 3 decimals and you're good to go. Are you guys comfortable with finding slope from a function? Finding slope from a table? Okay?
Yes.
He says yes. All right. After surgery, this is probably the hardest question on the paper. And it's not because it's a difficult question. Just because people aren't sure how to answer it. After surgery, we are given a pain reliever. The level of the medication will decrease slowly over time. Let C of T represent the medicine's concentration in your body. Write an expression of the rate of change of the medicine's concentration level over the period from time equals 15 minutes to time equals 90 minutes. In the previous two examples, in order to find our rate of change, we were doing y2 minus y1 over x2 minus x1, right? In fact, I'm just going to write that. That's all we were doing. We were given x1 and x2. We were not told the concentrations, and we were not given an equation for C of t, were we? If we were given an equation, what would we have done with the 90 and the 15? We would have, someone said it, we would plug them in. Plug them in, right? Because over time, the amount of medicine you have in your body should be decreasing, right? Your body's breaking it down. You would plug them in. What does that look like when you're plugging in a number? Yeah, it looks like this. So our y values are C of 90 and C of 15. Since I don't have an equation for C, I actually can't find those two numbers. The directions don't say what is the rate of change. The directions say to write an expression for the rate of change. Well, here is an expression for the rate of change. Yes?
How do you identify which is X and Y?
I was waiting for that. Someone asked the exact same question last period too. So how do we know which one is X and which one is Y? Whenever you say letter of variable, so f of X, G of T, H of N, whatever, the of part that's inside the parentheses is always your input, always your independent. It acts as your X. So think about it like this. Input's inside. Input is always X. So if it's on the inside like that, that is your input values, and the whole structure is your output values. Welcome. I was ready for it. Someone asked the exact same question last period. Yes, sir. What can I do for you?
Is it time also always the Y?
In this one, time was the X value. So no, we can't make any assumption like that. It basically just needs to be in the context of the question, okay? Because they're all going to change. Distance over time. Anybody that's currently in physics or have taken physics, tell me what distance over time is in reality? Velocity or speed. Yep. Distance over time. That's it. Here's time. Here's distances traveled. It says, what is the average rate the car travels? That means from beginning to end. Here we begin at 0, 0. But you end here at 120, 100. Normally, I would have to do the slope equation, right? But my x1, y1 is 0, 0. It's right there. So the slope equation is actually kind of a waste of your time. Just do total distance, 100 miles, over total time, 120 minutes. When you describe someone's velocity or speed, do you say distance, do you say your time measurements in minutes? No. How do we do speeds? Per hours, right?
Yeah.
So how many hours is 120 minutes? 2 hours. $100 over 2 is 50. That's the average rate. 50 miles per hour. How fast is the car going from t equals 30 minutes to t equals 60 minutes, but be sure to change minutes into hours. It doesn't matter if we do that in the beginning or if we do that in the end. This one's pretty easy to do at the very beginning, so let's just do it. How many hours is 30 minutes? Half of an hour, good. And how many hours is 60 minutes? 1 hour. Those are our inputs. At 30 minutes, we've gone 20 miles. And at 1 hour, we've gone 40 miles. Distance, 40 minus 20, over time. 1 minus 1/2. That gives me 20 over 1/2. And mathematically, dividing by 1/2 is exactly the same thing as multiplying by 2. Because of the whole keep, change, flip, whenever you divide by a fraction, you actually multiply by its reciprocal. Average rate of 40 miles per hour. Yes, sir. Those are the y values. Right there. Yeah, that's 30 minutes to 60 minutes. And these are the distances associated with the 30 and 60 minutes. You got our inputs and outputs mixed up, huh? How about this one? When, from this t to this t, when is the car traveling the fastest? And how did you know that? Is there?
From 70 to 90.
Yes, but how did you know that? Hold on, so from t equals 70 to t equals 90. How did you know that? Looks like it. What about it makes you say that that's the fastest, sir?
Is it because it's the steepest?
It's because it's the steepest slope. That's why. You could have. I mean, you knew that that was the answer, which means you knew why it was the fastest. You just didn't know how to say it in words. But it's literally because it's the steepest positive slope. From this x to this x. How fast? Distance over time. Go Gators. Distance from here to here. We ended at 80, we began at 50. Yes? Yes. 80 minus 50 over, and the time is 90 minus 70. Be careful though. That's minutes. How many 20-minute periods are there in an hour? 3 of them. So this is the same thing as saying 30 over 1/3. So dividing by 1/3 is the same as multiplying by 3. What we get is 90 miles per hour. Because 20 minutes is 1/3 of an hour. You have any questions about that? I'm happy to help. No? Okay. Example D says, what is the slope of the graph between t equals 90 and t equals 120 minutes? 90 and 120. At 90, the distance is 80, and at 120, the distance is 100. So y values 180, 100 and 80, not the number 180. 100 minus 80 over 120 minutes minus 90 minutes. It gives me 20 miles over, does that say 30? Nah, yeah, 30 minutes. So if you go 20 miles in 30 minutes, how far did you go in 1 hour? Yep, just double the top and bottom. 40 is our rate. It says, what does the slope represent? It's the speed. I'm not really sure why that question is here. That's what it represents. Yeah, just 40. Or do you think you should have left it as 20 miles over 30 minutes? But we can't say 2 over 3. Without units, it doesn't make any sense. You'd have to say 2 miles over 3 minutes. You could do that.
But it didn't ask.
But AP requires units for everything. Yeah. The slope is just 40. The context is, that's the speed. And the very last thing, told you this lesson was short and easy. Speed of the cart, 45 minutes. I'll do that one in red because I haven't written in a lot of red today. Let's find 45 minutes. It's right here-ish. Now here's the thing. We don't have a pretty point there, do we?
No.
But here's the good news. That coordinate that I just circled in red is in the middle, quote unquote. It's part of a straight line. That means everywhere on this line has the same rate. Everywhere on this line has the same speed. So all we have to do is figure out what the speed is, the rate of this line, and we are good to go. Our x values are 40 minutes and 60 minutes. Our y values are 30 minutes and 40 minutes. $40 miles, not, I said minutes, didn't I? I'm sorry, miles. 40 miles minus 30 miles over 60 minutes minus 40 minutes. Oh my God, I'm going to have to pause the video for this. Okay, interruption is over. This gives me 10 miles over 20 minutes. And just like the last time I had over 20 minutes, there are 3 of these in an hour. So it's triple the top and bottom, and you have an hour on the bottom. And what you get is 30 miles in the 60 minutes. So 30 miles per hour. That is the speed of the car at 45 minutes. We made it, nerds. Appreciate you.